an important problem of transformation of coordinate axis, that is from the geometry of two dimension. And the problem is, if AI, the coordinate of AI is xi, yi, which is run through I equal to 1, 2, 3. That is, we get 3 points. Be the 3 points in the plane, then show that the determinant x1, y1, 1, x2, y2, 1, x3, y3, 1 remains invariant under the rigid motion. Okay, and if we prove this result, then clearly we get another result from here, that the area of a triangle is invariant under the rigid motion. Okay, from this result we directly write this result, because the area of a triangle is half into this determinant. Okay, where 3 vertices of the triangle are A1, A2 and A3. So we first prove this result. Now, what is a rigid motion? A rigid motion means there be a translation and also a rotation. Okay, let this be the old coordinate system. This is x-axis and this is y-axis. Let the new coordinate axis becomes this type. Okay, this is new coordinate system, O x dash and O y dash, O y dash, and let it be O dash, and the new origin be alpha beta. Okay, so we shifted the origin from 0 0 to alpha beta, and let there be a rotation of angle theta. Okay, we already write here, if we give a rotation of angle theta, then the matrix of rotation is given by this, and since there be a translation and a rotation, then the formula of translation and rotation are given by x, this is equal to alpha plus this is x dash cos theta minus y dash sin theta, and y, this is equal to beta plus x dash sin theta plus y dash cos theta. These two are the formula of rigid motion. Okay, that is translation and rotation both. Now we write the result for xi. This is equal to alpha plus xi dash cos theta minus yi dash sin theta, and yi, this is equal to beta plus xi dash sin theta plus yi dash cos theta. Okay, now if we take this is equal to delta, then we write this determinant by putting the value of x1, y1, x2, y2, x3, y3. Here I, this is equal to 1, 2, 3. We get the result as alpha plus x1 this is x1 dash cos theta minus y1 dash sin theta. This is y1, this means beta plus x1 dash sin theta plus y1 dash cos theta, and this is 1. And similarly, by putting all the value of x2, y2, x3, y3, we get the determinant as. Now this determinant can be easily written in the product of two determinant. Okay, and what are this type of determinant? This type of determinants are, we write the second determinant first. This is obviously x1 dash y1 dash 1, x2 dash y2 dash 1, and this is x3 dash y3 dash 1, and this determinant is obviously cos theta minus sin theta, and this is sin theta, this is cos theta, and this is alpha, this is beta, this is 0, this is 0, this is 1. Okay, if we multiply this and this determinant, we get the above result. Okay, and clearly the value of this determinant is obviously equal to 1, because if we expand this determinant with respect to the last row, then this is 1 into cos square theta plus sin square theta. So this is 1 and this is obviously delta dash, where delta dash, this is equal to this determinant but in the dash system or in the new coordinate system. So we say that delta, this is equal to delta dash. That is, this determinant is invariant under rigid motion. Okay, and we know that if delta, this is equal to delta dash, then we know that half into delta, this is equal to half into delta dash, and half into delta, this means area of the triangle. Okay, we write here a note, area of the triangle is also invariant under rigid motion. This is very simple but interesting problem of rigid motion or of transformation of coordinate axis. Right? Thank you for watching.